So, welcome to the AI Edge podcast. And today we receive two guests. We have Bhaskar and we have Ilya. Welcome, guys.
Thank you. Thank you, Lemon.
So, guys, could you tell me more about you?
Yeah, maybe I can go first. So, hey, hi everyone. I'm a data scientist, and with more than approximately 9 years in the industry now, and I've been working in many different domains, including retail, FMCG, airlines, and for the last 5 years now, I've been working as a quant data scientist, where I
Hmm.
build predictive models using AI/ML to predict financial markets. And I also teach as well. Teaching is one of my passion, and I've courses on Coursera and MIT professional in education. And yeah, so this is a very brief introduction about myself, and yeah, excited to be here. I mean,
Great. What about you, Ilya?
All right, so my name is Ilya Biometov. I'm a chief of product for a company called Constructor Technology. We're in Switzerland, although I live in the US, and we are an ed tech company. And there's this long tradition of using AI in ed tech with its up and downs, and it goes back to the 70s. And then ChatGPT basically completely broke every trend and infused like some new energy into this field. So we can definitely talk about how AI was used in education in tech and will be used in tech, and what are the hopes and what are the expectations and all.
Well, let's go for it then. So, tell us how the AI was used before ChatGPT and how it is used now.
Right. So in education, right, the primary use of AI was it's called an intelligent tutoring system. So essentially, the ultimate dream sort of all the computer teacher, right, is to have somebody always with you, like Alexander the Great has had Aristotle, basically his partner in life up until the moment, right? And that somebody will be constantly sort of looking over your shoulder, right? And somehow improve your learning outcomes, right? That's the dream. It's a dream because you cannot possibly, and I mean, unless you are, king of Macedonia or whatever, you cannot actually hire people to be constantly with you or with your kids, right? Like to just constantly with them, teaching them and whatnot. I mean, that was available to, like I said, to kings mostly and to nobility in the Middle Ages, but not to ordinary people and not today. Now, the one of the most popular paradigms was with ITS, intelligent tutoring system, right? So basically, you build a domain model, right, which is the map of knowledge, so to speak, right? And it
Hmm.
includes also it includes like concepts that you need them to understand, and also how to get from understanding concept A to concept B, right? And concept C to directed graph, and along the edges of the graph is you know the exercises you need to do to improve that kind of skill, right? To move along this kind of learning curve, learning path, and it actually worked pretty well. Uh, to be
Hmm.
honest, the problem was that there are several components to ATS. First is the main model. Second is a student model that reflects your understanding. So basically, at every concept, right, you can have like a mirror of this graph that at every concept has like your usually a probability sort of you understanding this concept, to the fullest, right? And then there's a tutoring model, which is how do I specifically get you from like considering what you need to learn in a domain model and what you know in a serial model, right? How do I improve your sort of your state of understanding? Now the problem is that for every domain, which is basically every course, you will have to rebuild this the domain model and the tutoring model, right? And you will do it by hand. So basically, you need a team of experts. I don't know, three PhD students, basically, right, and one professor to do it, and it will take them a year. And considering the average number of courses in a bachelor program in the U.S. university is what 40, 45, right? So that's just insurmountable amount of work. So ITS has worked very well, but it was mostly either it was used for, let's say, for school, because if you build one for Algebra 2, you can use it at every school, right, in every
Yeah.
school everywhere, and it will be reusable, which some of the people did actually. or it's impossible to build because every course at every college is different, right? So in college, it's very much a personal sort of a message from a teacher, from a professor. And GPT, of course, changed all of it completely, right?
Hmm.
Because it sort of knows everything. So this
Yeah.
domain model, and even the tutoring model, because we all have some materials there, right? And it was trained, it all exists somewhere inside. The problem is now, can we extract it using the prompts, right? Also, and of course, quality of the output and whatnot, but the problem was completely flipped on its head, right? So in terms of instead, it was a very laborious, tedious, long, very kind of long and expensive process of manual labor of highly qualified people before. And now it becomes more of a, we can probably compile these prompts pretty fast, but can we trust the result? Right. So how do we
Mm.
actually how do we make sure that the result we're getting from is actually good quality? The issue here is that this ITF will be, as soon as you build it, it will be left alone with the student, right? And we know that these models, they're glitching and hallucinating and do some, and sometimes start saying kind of stuff that we don't want to hear or we don't want to be
Yeah.
taught to the students, right? So that becomes so basically it completely changed the set of skills and the set of issues surrounding this thing, right? And the
Ca-
second,
ca-
go ahead.
can I
Yeah,
interrupt you one second, just because I would like to make sure I understand completely. You said a lot of things, so let me ask you first, like, what does ITS stand for?
intelligent tutoring system.
I see. I see. I see.
Intelligent
So
tutoring system. It's a common
I see.
in tech. It's sort of in this in this scientific field of research. It's a common act.
Yeah, I'm not very familiar with that domain. So, and so I just wanted to come back to the actual model that was originally there. So you have a graph of concepts,
Mhm.
right? And this graph is built using experts.
Yep.
There's no machine learning in building that graph, right?
No, because basically up until large language models, right, the arrival of them, it was very, very hard. Not actually, I'm not even sure it was possible with any sort of decent quality to basically feed a textbook into the computer and get
Yeah,
like a concept graph out of it. You will probably
I
have
think
to
that.
spend as much time editing it afterwards and verifying as you would just build it by yourself if you're an expert.
So yeah, very likely. Yeah. So then, as the student progress, you're able to build some probability of understanding to go from one node to the other. Is that correct? Or
Yeah. So as you progress, right? So essentially, what happens, you are given certain problems to solve, right? Because that's the benchmark. That's the only thing we know how to verify if you know something, right? And again, this will have to be built by an expert, like the complexity of the problem, which skills. It's not just concepts map, right? The domain model. It's also skills that you need to have. Like
hmm
if we're
hmm
talking about like I don't know multivariable, whatever it's called in English, calculus, right? You need to be able to solve certain types of equations, differential equations, some
yeah,
kind of do some symbolic manipulations. So this skills also, right? So when you compile this problems, right, you need to, as an expert, you need to specify which skills they develop and the complexity and basically all sorts of this complex
mm,
metadata. It's not that complex for people who are teaching at the universities, right? Because they kind of informally know it, but it still takes a lot
yeah,
of time to sort of to bring it to to the level of actually to verbalize it, right?
of course.
Another issue there is you need usually several of them, because usually there's a well-known, there have been well-known studies that if you ask an expert to sort of verbalize their domain area, right, so their domain, they will only tell you about 30% of what they actually know. So if you
Mm,
for example, if you ask, I don't know, the Bhaskar to tell us all the important concept in data science, right? He will come up with a list, but then actually he knows at least three times more than he would be able to just write it off the top of the head, or off
of
the top of
course.
his head.
Of course.
So as soon as he starts getting into like solving real problems, so you'll find out that he actually missed a lot of things. It just didn't come up to him, like in a
Yeah,
sort of
yeah.
in this kind of global explicit form. So you need several experts that will sort of, work with each other and kind of extract this knowledge. And yeah, that's anyway. So I don't know.
So you have problems that can be associated to each of the nodes in that graph.
Hmm.
And as the student progress, you're able to establish a probability of understanding by how much the student was able to solve in terms of problems,
Yeah, for the
right?
degree of understanding, yes, probability of understanding. So basically, if you know these things pretty well, right? So we think you will know that thing also. You will be pretty good at that too.
I see.
And that's
So
usually,
if
it's a usually simple Bayesian graph, basically. So it's like a, mhm.
so by establishing how much you know for a certain concept, you're able to understand what will be the next node that we should send the student to,
Mhm.
because the student will be able to complete his understanding of the subject by addressing that slightly similar node. Is that
Yeah.
correct?
Yeah, so basically, to
I
develop
see.
certain skills, right, we give the student these problems to solve, and then we assess uh, how they answer, right, and by the quality of the answers, we can assess the overall knowledge. And of course, we can, if this sort of level of knowledge is not sufficient, we can just keep giving problems, right, and keep like
Mm,
developing these skills. And actually, also, it's a very uh, established kind of fact that you need several kind of several attempts to build up a skill.
I see. And the are you are you saying that this is machine learning that is deciding
Yeah,
what?
this is yeah, yeah,
Yeah.
yeah,
So the machine learning aspect is only in deciding what is the next node to learn about.
yeah. That's pretty much how it just works, right? So the output is that what set of problems do I need to give to the student to develop the skills they're not yet proficient enough in, right?
I see.
To
I
achieve
see. I
the
see.
final sort of to achieve the final level of understanding. It kind of it sounds kind of simplified, and the problem, of course, is that if you know what a concept inventory is, it's a qualitative kind of test of your knowledge. There's a very famous test called force concept inventory, and basically you can be very good at solving problems, meaning uh, recognizing a certain pattern, uh, uh, recognizing what formula it fits, pulling up this formula, putting the numbers in and getting the answer, and still don't understand the physics. For
I
example,
see.
of the of the
Yeah.
of
Yeah.
the Newton, like a simple 3 Newton law, right? Yeah, that's serious. But I mean, you can basically you can include this with force concept inventory also in in a part of problems, right? So it just depends on the problems you give to the
Mm.
student and the method of assessment. But yeah, that's how it works. Mhm.
And how do you ensure that the student cover all the different points in that graph?
By giving them all the problems, do all sorts of problems.
Okay.
So, like I said, it's an art, right? So, compiling the problems that sort of, the, so you have this graph of concepts, right? But you need
Yeah.
to sort of cover it with a minimal effort, right? So meaning with minimal number of problems that will be given to you, and you need to develop all the skills. So that's an art of the teacher. How do you
So
basically? Mhm. Go
okay, but sure, it's the art of the teacher, but we have here an algorithm that is deciding where to send the student to when it comes to the next concept to learn. So how do you ensure with this algorithm that the student is going through each of the different nodes in that graph?
But like I said, right? So you imagine you gave them a set of problems that develops like I don't know 5 skills, right? So
Yeah.
basically the root is like zero, and then you need to have
Mm,
these kind of you need to have the right of understanding these kind of 5 concepts, right? So you need to give them problems that develop understanding of those 5 concepts and skills related to it. So it can be just one problem that develops all of them, or it can be 10. You need maybe 10, right? So you basically give it to all of them. So at these ages, right? You basically specify what is the exercise I need to give to that person, right, to develop the skill. And that kind of similar to, if you, I don't know, if you're doing fitness, right, you could do like a biceps or whatever or something, or you could
mm.
do like a full body exercise, right? And, uh, that develop maybe everything at once. And that's an art of your personal trainer or here an art of a teacher to arrive to the destination in a minimal sort of minimal number of steps, minimal effort, right? Because you can beat students up with like a thousand isolated exercises that develop like just a certain technique, right? Which is probably very boring and not very efficient. Or you can, that's why textbooks, there are some gold standard textbooks on the subjects, but there are even fewer and even more valuable gold textbooks, kind of gold standard textbooks, or not textbooks, the problem books, exercise books. They actually even sort of it's a sort of there's a implicit understanding that to combine a book with full of great exercises, a great problem set, is actually harder to write a good textbook.
So, but I think I'm still confused about something. So
Mhm,
let me make sure I ask the question correctly. So I think I understand that we have an algorithm and we have also a teacher that is part of
mhm,
the equation. The teacher seems to be able to help the student focus on some set of exercise, and the algorithm seems to be able to decide or to advise what should be the next concept to learn.
mhm.
And potentially the teacher is going to follow that advice or not, right?
Y-
So,
mhm. Go ahead. The next concept to learn is actually kind of predefined by the course itself, right?
okay,
What's not predefined is you sort of need to uh, as you go along this graph, right? As you're progressing along the course as a student, the system starts recognizing that you might be not as proficient as required in certain things that were in the past, for example. So it will have to sort of give you more exercises to bring the stuff to the required level or something like that. So that's where
okay,
the
I see.
adaptivity comes from, right? That's the adaptivity sort of that enters the system. It's not so much in what is the next concept to learn, because if you have a course on, I don't know, the game theory, right? You're learning things like you learn like, I don't know, mesh equilibrium and whatnot, right? So it's a more or less somebody has already decided. But what
Okay.
will be the problems you will be solving? That could be modified
Okay. So
to. Mhm.
the model is giving you your weaknesses and your strengths.
Yes, it's trying to develop your weaknesses. Basically, it's trying to detect and develop your weaknesses. Yes.
Yeah. Yeah. Okay.
Mhm.
I think I understand. So the model is purely about insight for the student and the teacher to decide what will be the next set of exercise to work on.
More or less, yes. Yeah.
Okay. 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 And so I think I understand where the machine learning used to be or is. And when it comes to how it is done now, I would assume that where ChatGPT or large language model can help is in building that knowledge base of concepts.
Yes, but it's actually not even clear that you need to build it anymore, right? Because it's inside. So basically, it is inside GPT already. So the form of the tutoring that is considered to be the most efficient is called Socratic dialogue, right? So it's a Socratic tutoring. So meaning that the system doesn't just tell you, "Aha, I see you don't quite understand, A, B, and C. So go, sit down and solve some problems." And then I look at your solutions, and I basically, and we will just rinse and repeat. The most efficient tutoring is considered to be basically asking questions to the student, right? In a way that they discover the right solution themselves, and they then understand by kind of reflecting and whatnot what they've done, what kind of mistakes they've done. So that's considered to be by 100 years of like psychology experiment, the pedagogical experiments. That's sort of considered to be the more effective way of teaching from the standpoint of sort of the quality of the outcomes. Right. And with ATS, it's actually hard to do kind of because it requires sort of the additional sort of level of intelligence. I mean, I'm putting it in quotes from the models that were not available. Uh, GPT-4, you can actually prompt it like be a Socratic tutor or be a tutor and ask me questions, right? I can literally say, be a Socratic tutor. Let's have a Socratic dialogue. And it will actually do it. Although, uh, the typical problem with ChatGPT, as you guys probably know, even ChatGPT 4, the latest one, when you talk to it, you have a feeling that you're talking to like a high school student that just read all the Wikipedia last night and basically just gives you the answers like this, right? So there's no depth. There's no really real kind of. It's very hard to extract something like profoundly insightful from it. Maybe there is nothing. Maybe it's not there, or maybe it might be it's there, but it's not in the mainstream. Meaning this kind of probabilistic approach, right? It gives you sort of it tends to give you the mainstream answer, or it goes so off that it hallucinates. It never there's no like originality kind of path or whatever inside built in inside these models. So. But yeah, essentially, you can right now. It can right now emulate the Socratic tutor. The problem is how to make it, how to do it with a good quality, right? Because the sort of human art of being a Socratic tutor is that your questions back to the student need to be very insightful. They need to incite the insight, right? So they need to sort of induce this kind of thinking process that will lead to gaining new insights. It's kind of very hard, and not every humans actually can do it. I mean, not every human teacher can actually do it well. Like let's say that, right? Mhm.
Let's make sure I understand. So let's say I ask a question to a student,
Yeah.
and the student answer, and instead of saying that the answer is right or wrong, I'm asking again another question that will push the student to think further about the initial question, right?
In a certain way, right? So for example, imagine you're teaching like history of the United States, which is the country I'm in right now, right?
Hmm.
And let's say the history of like Civil War, 1870s or something. I'm not originally from here, so I don't know the exact date.
Mm.
And then and then basically you ask the student, tell me like what were the most important kind of events during this war, right? And then they meet like one or two, then you think are the most important. And basically when they give you the list and something is missing, right? You may ask, and you think do you think this period was like quiet and there was nothing that changed the course? So, I mean, it impacted the course or something, right? And then they maybe start to remember. So basically, it doesn't, it has to be very sort of indirect and not very leading, right? So in judicial terms, there are leading questions, right? And there are just questions. So you don't you need to be not very leading in your questions, but you need to just kind of give them the hints that there might be
Yeah,
something they need to go and discover by themselves. And that's very hard to do
and
efficiently
within the
again.
and within the context of ITS or education, the type of questions that need to be asked are problem sets that need to be solved, right? They are not like simple questions like that. Correct?
Yeah.
Am I wrong?
So, well, it's still, you know, this again, we only have the model of education we have, which is you sort of ingest some material, you go solve problems, right? You go do the exercises you discuss. So I mean, the lectures are now kind of being diminished more or less, right? To although again, it's a performance. So because it's a performance, it could be engaging and insightful. I mean, it's a performance by a professor, right? But anyway, so we know again from 100 years of psychology that working on the projects is better than working on just some kind of solving problems that have no context. We know that working in
Hmm.
groups is more efficient and all that, right? So, but we also know that working with the tutor is super efficient. Now, right? So all of this kind of comes into play. And okay, sorry, what was the question? I went somewhere else.
Basically, I'm asking if so originally we talked about concept that the student had to learn, and we were assessing how much the student was knowing about the concept by looking at the different problems
Yeah.
that the student solved. So when you talked about how ChatGPT can provide a lift in helping students when it comes to learning, I would assume that ChatGPT would actually providing the problem sets like we talked about in the context of ITS.
Yeah. So in the context of ideas, it's like I said, it's pretty simple, right? So basically, ideas. Imagine it's actually they were not that intelligent, in quotes, as I'm going to sort of describe it to you, but just imagine, right? So it looked at the solutions that you gave it, and it sort of
Mm-hmm.
understands that you have certain insufficient understanding of certain concepts, right? And then
Mm-hmm.
basically it may tell you that I think that you have insufficient understanding of these concepts. Therefore, I think you need to do these exercises to solve more
Yeah.
problems. Basically, that will
Yeah.
and right. So the Socratic tutor, which is now possible, I think maybe we don't know actually because we're still experimenting. And by I mean like with good quality and like good effectiveness, right? It will not give you the new set of problems right away. It will engage in a dialogue with you, right? And not in a dialogue that starts like you made a mistake, but in a dialogue like let's examine your solution, right? So explain to me why why such and such, right? And then
Mm-hmm.
as
Mm-hmm.
you sort of student, as you go through this experience, I mean, I don't know, guys, anybody, I think most anybody who actually had a really good teacher in their lives, and unfortunately, it's an increasingly rare, actually, it's an increasingly rare sort of occurrence. Uh, you would probably understand the difference between like a regular teacher who basically acts like, I don't know, like more or less like a chat GPT. They go in the class, they
Mm.
tell you something, you listen, they give you very sort of shallow kind of the interaction is usually very shallow, right?
Yeah.
So you made a mistake, like it actually such and such. So sit down. Thank you for your whatever for your question. But a good teacher, they will actually engage with a much more meaningful dialogue. The meaningful dialogue is far in our lives because it requires a lot of time, both from student and the teacher, right? So these dialogues usually would happen in either extracurricular activities, like if you go to some kind of math circle, kind of Russian style, for example, right? Or um, I don't know, something like that, basically, right? So when
Mm-hmm.
there's like there are two students, they work on something uh, difficult, like not really, kind of, kind of, American school kind of problems, but actually something much more sort of involved, and then the teacher will engage in this kind of dialogue with you if they want to really develop, if they're not just prepping you
Okay.
for SAT, right? So that's the desire. That's what we want to get out of ChatGPT because it seems to be the potential seems to be there, right? Is it possible? We still
S-
don't know.
So I'm still trying to make sure I understand. Okay.
Mhm.
So the student needs to learn on his own, and the student needs to solve some problems. And this is something that will be disconnected from an interaction with a teacher or a tutor, right? And ChatGPT here or large language model could be used to probe the student in looking maybe at some problem set, asking some questions to the student to uncover some potential weaknesses. And I think the goal would be for the LLM to advise what would be the next set of subject to learn about and the next set of problems to work on. I think that I
Yes.
think
So that's the way, what you described, right? It's like, let's repeat the ITS exactly in the way it was in the past, but let's just make building it much more efficient because we don't have to build it anymore, right? It's built already. I mean, LLM has
okay.
all these kind of connections inside, so we can just prompt it. That's one way. But like I said, the next kind of step is Socratic dialogue. So instead of just advising you a new set of problems, it will engage in a dialogue with you discussing your work that you've already done, like literally
So, but
discussing.
yeah,
Mhm.
I understand that, but we cannot learn only by having a conversation, right? We need
Uh,
at some point to sit down
oh yeah, yeah,
and
yeah.
right.
But
So
this
we
conversation.
are,
Mhm. Go ahead. Sorry.
go ahead. No, but the conversation, what does that lead to?
The conversation leads to significant reduction of the time you need to really learn these concepts. And in the end, if you do this kind of concept inventory test, like the qualitative test, people understand this much better. So basically, this kind of idea cycle, right? So it can be long, it can be tedious for a student because it's constantly need to like, continue solving problems and whatnot. But also there is no reflection there. There's no point of like self-reflection or meta learning or whatever it's called, right? And Socratic dialogue is all about that. So basically, it's just in a very primitive sense, right? It's just explain to me why you did this. Like why, if there are two formulas in your solution, right? You do like here, and then from that, the follows that. And if it's not trivial, for example, like explain to me why, or why you chose to go this path in your solution and not the other one, right? So there was an alternative, for example. Explain to me. Explain. So that's the dialogue. And again, from the psychological research, we know that this significantly, at the same time, reduces the time required for a person to master certain concepts and increases the real kind of depth of understanding of these concepts. And that's the
I'm a
holy
bit,
grail. Mhm.
I'm a bit surprised actually by the statement that this is the best way to learn. I mean, I'm not going to say this is not the best way to learn, but personally, when I learn, I need to sit, maybe take a piece of paper, write down some equations, or read a paper on my own, take some time to think about it. Like even I do some good thinking by just taking a walk and thinking about it. So the idea that I need to communicate to learn the concept and to understand it better seems a bit strange to me. I mean, I understand that there could be a conversation to spark some thoughts about the problems, but it seems to me that that cannot be the only aspect of that leads to a good learning.
No, it's not the only aspect. Of course, you need to work on yourself, but that's a very important aspect. Actually, there's a sort of what's it called? Constructive, basically uh, social constructivism by Vygotsky. It's a 100-year-old theory proven, over and over again that the best way people learn is in groups, in social
Hmm.
environment, and there needs to be a person who's called the more knowledgeable other, which could be the teacher, or at any moment of in time, it could be the other student in the group that actually help you to go through understanding certain concepts. And there is also the concept of the zone of proximal development, meaning that there are certain things you can comprehend and you can master, not by yourself, right? So there is a certain sort of like if you are here in terms of knowledge, right? There is certain sort of vicinity that you can master all by your own, but there is certain uh, slightly sort of larger vicinity that you can master if helped by somebody who actually knows this already, right? And that's how efficient learning happens. So you need to be sort of pulled through this thing, right? So otherwise, you will just learn slower. And even the most genius people I know, the best learning experiences they had, they're always in groups and they're always working on some concrete projects and they're always mentored by somebody, right? So when you say sort of I need to like think and internalize some model, yeah, that's an important part. But in the end, we need to be in a social group and learn socially and with a mentor. But that's how
But
because that's how we learn. That's how evolutionary we evolve, right? So you always learn in a group. I mean, people lived in tribes, usually small ones, and there is always somebody to teach you to do something. There's like your father or uncle. I mean, there was no difference, but 20,000 years ago, that will teach you to throw a, spear or to run after,
yeah,
a gazelle or something, and so much and so. I mean, and
but
so forth.
when you say learning in a group, uh, it doesn't mean that we are all sitting in the same room and we always have a conversation about what we learn about. But it's can also be about having, when we need to, a community to who we can ask questions about the problem that we are trying to think about or solve, right?
Yeah, but ideally, you're actually sitting in the same room and doing the same thing.
Oh yeah,
Yeah, discussing
and
with each
and
other.
it's
You're working literally in the same project in a small group of 2 or 3 people.
and it's not dependent on the specific
No,
subject.
no, not depending on anything. It's just the best way to learn. The problem with like IT people don't understand it, and I'm gonna say something politically incorrect for IT people. Like developers, they think they're actually very smart because they're getting paid a lot of money, right? So and they think they're because they're sort of in our society, who gets more money is the basically uh, is the, I don't know, the person, the right person, right? The person who's always right is the person who has the most money. So they think the way they work or they operate or whatever is the most efficient or the best one, because it leads to begin, see how much I'm getting, right? And you are whatever carpenter, and although carpenters are now maybe actually getting paid more than programmers even. But anyway, I'm digressing. But anyway, so and the way programmers learn is we write programs, right? I mean, I used to do one, so I'm still kind of dabbling. So you write a program and you see the results immediately, right? So this kind of learning loop happens on its own, but simply because it's a very narrow medium that you can always test your results, right? And you can kind of see where your mistakes were by yourself. So it will still be more efficient actually to learn in a group doing the same thing. And the pair programming kind of technique, right, which is very famous. It actually, I discovered that before I read about it. It's just in 1988, we didn't have enough computers for every student when I was studying, right? And me and my buddy, we were developing literally like pair programming. So we were just sitting together, right? And we were kind of, if I have like a block, he would just kind of continue, right? And so we were working together and say that was extremely efficient, we were extremely productive. Much more productive than if just each of us would just do, their part, right? Basically, right? So it's an anecdotal experience, but kind of, in my opinion, confirms the what psychologists are, telling us, have been telling us for 100 years, pretty much.
It's
But again, as a developers, we have this learning loop, and it's working for us. It's working pretty well, right? Because we can always test the code, we can see the mistakes. Compiler tells us, the tests tells us, and this whole kind of TDD thing is also kind of with a certain discipline. So maybe we have such a decent approximation of this tutor already being there by this compilers and test systems and the unit tests and whatnot that we do. They're kind of playing this role, and we have like a kind of decent approximation. It's still not by far not there, but we are extracting a pretty good learning experience. But if you're learning like biology, like or whatever, or even I don't know, literature, like so, you need to talk to people. Even if you're learning math, actually, just math and physics, you need to talk to people, because in math, like you cannot just. I mean, some people did, of course, like Ted Perelman or guy who proved the Fermat great Fermat theorem. Yeah, you can just be on a farm for 7 years doing nothing but just doing this. Uh, Things like that happen, but there are exceptions even in math and physics. Most of the stuff, right, is done by people working together in confined spaces, like Manhattan Project, for example. Do you think Manhattan Project could be done if people would just send home, write formulas, and not come back with your ideas, and then kind of go home back and come back again? I think it will take it would have taken significantly longer. Anyway, sorry. Go ahead.
but there's a difference between brainstorming ideas and solving a problem. To me, it's not the same thing. When we talk about pair programming, we are not learning, we are solving a problem. And pair programming is good to go fast into solving a problem, which is not the same thing than learning. So it's true.
Uh,
It's funny.
Best way to learn
It's
is
funny
solving
because
problems, actually.
yeah, but it's not because you came up with a solution to a problem that you learn something. So that's a bit surprising what you said to me. I mean, what you're saying, because it does not fit with my experience. So, for example, I could consider two things that I've learned. I've spent quite a bit of time learning about math, and I spent quite a bit of time learning about English, for example, learning to speak English. I'm not great at it, but still had to go through this process to learn it. And definitively, when it comes to language, it's much easier to learn about it by having a back and forth conversation with somebody, right? That's the best way to learn a language. When it comes to mathematics, I learned it by uh, being stuck on problems and really spending time on my own trying to come up with a solution. And very often, when I I am in a group and I try to get the solution from somebody else, I don't get that deep learning experience that I would have if I spent really the time to uncover what are the intricacies of the complexity of the problem to come up to a solution. And it's where my brain tends to really connect things when I solve a problem, when I really spend time getting to the depth of a problem to solve it myself. And many times in the past, like in high school or in college, I was in a setting where I was, let's say, I remember working in in a lab course where we were in pairs of students and we were supposed to do, let's say, an experiment. I studied physics, so it was like physics experiment. And I can tell you that that experience as being one of the poorest experience when it comes to learning for me, because first of all, we have, we don't focus as much. We tend to have a bit more fun pairing with another student. And very often, we let the other solve one aspect of the problem. The I solve one other aspect of the problem, and in the end, we get results, but we both have a partial understanding of the different concepts that related to the specific uh, experiments we were trying to to put together. So
Okay.
what you're saying to me is somewhat disconnected from my own experience, and I have to say that I am somebody that really spent a lot of time learning about things. I'm not saying that I know everything about it, but I'm saying that I have some experience about what it means to learn. So I'm a bit surprised about
Well, you
your.
have the experience of learning by yourself. You actually don't have an experience of what I described, right?
I
Learning
have,
in a group with a mentor. And
I
they
have.
no, the task needs to be challenging enough. Remember, I told you, like, so there is something you can do by yourself on your own. There is something in ZPD, zone for proximal development, that you cannot do on your own. You need help, and that's where actually the learning happens. But usually, this kind of labs that you described, those are trivial. I mean, for people of sort of I don't know, for who are understand anything about physics, right? It's just not challenging enough. So it's trivial. Yeah, for trivial things, you don't need anybody. It actually kind of becomes helpful because you can just do it because you already know 100% how to do it. If you don't know how to do it, then it actually becomes so, in like mathematicians, I don't know, they have seminars regularly, right? Like weekly usually, to discuss stuff that they're working on with people who sometimes don't even in the same field. I mean, they're kind of right, but it's just you need to verbalize it and you need to hear some ideas from other people, and that's how you learn. That's how you learn. That's how you get insights. That's how you get you I don't know connections in your brain
I,
and whatnot.
I do not disagree with that. You need to have some interaction with a community of people that learn about the same subject or knows about the same subject, but it doesn't mean that you need to be in contact with that community 100% of the time. I think
No, not
that it
100,
can be
but
true. Well, you said that it's better to sit all the time with the different people in the same room and to have that group learning experience.
not
But
all, not, okay, not all the time, not 100% of the time, but it needs to be a very substantial part of your time, 50%, 30%, I don't know, something like that. So basically, it needs to be a constant experience, right? It needs to be a constant experience. So it's not like you get together once a week, right? And whatever. So if you're trying to actually learn something, try and just get together once a week for like mathematicians for seminars because they're super pros already, and they basically don't need that much help in between these weeks, right? But and also they can enjoying working on this hard stuff, and then so for I can give you an example. When they train kids for international mathematical Olympiads and physics Olympiads, those two I know, like I have like some experience in
Mhm.
observing, and they always train in groups. It's never
Okay.
like people get individual mentors that just train them, or maybe they go from like one mentor to another. And it's not because there is not enough mentors. There's plenty of, I mean, you have like a team of 10 kids from a country of 300 million people, 200 million, or half of 1.5 billion people, right? Which is like India or China, right? And there's only 10 kids, and you can find plenty of mentors. Still, it's always a group experience because it's again, these guys know that group learning just works better when kids working on
So
these problems together. But problems are super non-trivial, right? So I mean, they need to crack those problems are super hard, and that's why learning happens. If you're working on trivial things, yes, no learning because you already know.
I think that makes more sense to me. But the key point is really, like you said, having people that you can work with time to time on a regular basis. It has to be somewhat consistent, but you also need time that you can spend on your own to build your own understanding of things.
Oh yeah, yeah, that goes without saying, of course. Yeah, I mean,
But we didn't say it. We didn't say it. So
yeah.
that's what was confusing to me. Okay,
Okay,
Yeah,
things
we
that
I'm
make
ended
more
up
yeah.
sense.
discussing pedagogy, actually, pedagogy and psychology more than AI. But yeah,
I'm,
so
I'm, I'm curious to know one thing, if I may ask, Ilya. So that's a very interesting use case, of course. What I'm interested to know, or rather curious to know, is how do you evaluate your ITS system? Because every learner is different, right? And I mean, kind of mentoring or teaching is not one size fits all kind of a thing. So every learner will be learning in their own own speed or own pace. So how do you evaluate this ITS system, LLM based ITS system that you're developing?
just by experiments, you do experiments on people basically and students, right? And that's why it takes years to validate that the system is good. And that's another actually. So let me quickly mention other applications of AI potential applications, right? So for example, as a synthetic student. So there were experiments on building synthetic students before for ITS, exactly like a counterpart for ITS, right? So basically the idea is you build a model like a human perception system, right? So basically like of a cognitive learning, you build a model of a human basically, right? That you're trying to teach, and you vary some parameters. So you basically come up with like some sort of diversity in terms of their, I don't know, knowledge and cognitive abilities and whatnot, right? And then you try to teach them. Before ChatGPT, before this kind of really, marvelous to some extent capabilities in processing text, it was very, very hard. Now you can basically make ChatGPT talk to another instance GPT, right? And actually, it will be some kind of approximation. That's another kind of direction of research that is currently being undertaken. Is that can we now test these kind of ideas much quicker and with much higher fidelity, right? Without actually testing it on humans. The problem with testing on humans is actually there is an ethical aspect, because if you take one group of students of like you have like three classes of 30 people, right? And two of them are studying in a classic way, and then another one is subjected to this ITF and whatnot. You're putting them in an unfair position, right? So some of them will be sort of either better or worse off in the end, which is not, I mean, you're not supposed to do that, right? So if you are in a university, you're supposed to teach everybody equally and give them equal level of sort of experience. And by doing this, you actually automatically sort of putting them at the advantage or disadvantage, I don't know, depending on how good your ATS is. Right. So that's so synthetic student as well. Another big thing actually is just building materials and grading and grading given feedback, right? So ITS is like Socratic tutor is an ideal way for giving feedback, but sometimes you just need to go through whatever they've written, whether it's the physics or mathematical problems, right, or essays, and give them a good, thorough feedback on what they've done and a grade and a grade. And currently, it's not actually done very well. Can large language models do it? Probably they can do it better. Can they do it consistently at the same level of good human? We don't know yet, right? But constructing material, like how do you prepare for class? All this kind of how do you actually? So you have when you're building a course, it's like writing a mini textbook, right? So, and most of it is kind of routine, because if you know what you're going to teach, then basically filling it with words and phrases and whatnot, it actually seems to be much less of a intellectual effort than actually coming up with a system of concepts that you want to teach, right? And that again, that where artificial intelligence can help. LLMs again can help you. Not that that can write a course for you like at one go, but you can interact with them, right? And probably come up with this course much quicker than if you would just if you had just done it by yourself completely, especially when it comes to uh, uh, and for example the big part of it is visuals, right? Currently visuals are not very good. I mean, Midjourney is the best one. So the AI image generators, especially for like scientific subjects, they are kind of not there yet at all, right? So if you, so my sort of the way my I don't know attempt to joke about it is that if Midjourney is actually the best of them, and if you give a prompt to Midjourney and it gives you back the results, you go like, huh. I'm not sure it's actually what I asked for, but it's kind of fun to watch. I mean, it's nice to watch.
Mm.
And all the other models like Stable Diffusion and whatnot, you give it a prompt, it comes back and it's like this is some crap basically, right? So if you ask it to uh, if you ask it for a scientifically correct image, it will never give it to you. But like it should be, right? I mean, it shouldn't be that hard because there are plenty of images in the training database, scientifically correct and whatnot. So that's another basically area. It's just quickly, how can we quickly create and update courses with high quality material and high quality visuals and so on. So right, but
So
go ahead.
I think what you're saying is that with generative AI, we can generate stuff, but we don't have a good way to assess if that stuff is correct or not. Is that what you were saying with Midjourney and Stable Diffusion?
We do have a way to assess it. It's just a teacher who sits in front of a screen, right? But
Okay.
otherwise, uh, uh, so with text, we're actually doing pretty well, right? So a teacher usually to write a course, it's like a full-time job for like a year because usually they're developing slowly, right? So people have thoughts on their minds and they are slowly developing their courseware, presentations and text and whatnot. And by the time actually, okay, it's a year, I maybe all exaggerating, but still, by the time it actually takes a shape of a full kind of product, I would say, right, that you can actually give to somebody, it's a long time, especially in university, right? Because people usually talk in university and then they write it down and whatnot and make notes, build presentations. It actually literally takes years in most of the cases.
Yeah.
Now with
And
this
I
stuff, we
think
can do.
I mean, I think what I understood from you, Ilya, is maybe, how do you explain a concept visually, right? That's what you're saying.
Yeah, yeah,
For
yeah, yeah.
example, if you want to understand, neural network, for example, how do you initialize, weights and biases? How do you do forward propagation, backward propagation in a visual way? And these, models are not there yet to create that kind of visualization.
Yeah,
And that is what actually I learned. I learned it. I'm a visual learner. I learn, things visually first before I go into the mathematical details, to understand the intuition behind those algorithms. And yeah, I think, there are many different ways. I mean, I think these models are not there yet that you write a prompt and it will give you those kind of visuals. But yeah, I mean, Damien does a great job in explaining those in the concepts visually in his newsletter.
Daniel
And I also
does. Yeah,
share, visual resources on my LinkedIn as well. I've been sharing for a few months now to understand this, mathematical concepts in a visual and interactive and intuitive way.
yeah, exactly. And especially when you want the visualization to be interactive, right? So you want like an interactive simulation basically. That's where completely far away. But even just a static picture is actually very hard to get from these models. Text is easier to get. So for text, for example, right, I can sit down in front of ChatGPT and with a few iterations, it's kind of tedious, but in the end, it will still take significantly less time for me to create a text for the course, right? And then I need to, then I would just kind of basically be sitting down and writing it from my head. But for the images, we're not there yet completely. I mean, it's much easier and better, higher quality to just go on Google and search for an image than to ask the model to generate. When it comes to basically pretty much any scientific concepts or engineering concepts to understand. And that's actually another area of a very good sort of application of AI.
Yeah, a question for Damien. I mean, if you can share, how do you create those images? Those are very, visually appealing. Do you use some kind of models, like what Ilya has
Models?
been?
I use Canva. So I started to use draw.io to make those images. and I ended up to use more and more Canva.com. And yeah, I mean, the it's not about the software, it's more about the format. I think I started to publish those diagrams on LinkedIn, and to be able to bring the attention of people, I had to build images or diagrams that were concise but also useful in one image. And it's something that you usually don't do in most other media. Like if you write a scientific article, or if you write a textbook, or if you write some some explanation, like a text explanation about something, you don't try to be extremely concise because you can actually expand on
Yeah.
what you explain by having multiple images. But in a on a social media, you need to be able to have all the information on one image, and it has to be useful for people to, you know, to get to be excited about it. So that's what taught me to make those images, I guess, to try to make sure that when I build an image, it's concise and there's no unnecessary information. Everything that is there is useful for a learning experience. And I would say that we, we learn a lot in a visual manner. We learn a lot by looking at images, but we also learn a lot by making things, meaning that I learned myself a lot by making those images. So I need to
Yeah.
make sure that I understand enough the subject to build an image, a diagram that is concise enough and accurate enough to provide the right information. And this was a great learning, is also a great learning experience for me. So it helped me learn a bit even more about the subject,
Yeah.
more than just looking at images in a passive manner. So being active really helped me learn more about the subject that I'm trying to educate people on. So
I
yeah,
think, Ilya, I mean, those models are not there yet to create Damien like, pictures,
No, no, no,
images.
no, no.
Yeah.
And
that's
with
good for me.
images, but also, if you, but that's, remember I told you in the very beginning that to any expert, when they try to extract like an expert quality work from any of these models, even at the level of text right now, right? It actually, it's not satisfactory to any of that, because you have people have certain style, or people know how to write more sort of in a more engaging way and whatnot, right? And what LLM gives you is like just an sort of the mainstream kind of how most of the people do it, right? It's basically what's the most of the text on the internet are, and the most of the text on the internet generated by people who didn't uh, pour their souls, so to speak, into creating it. So the material they learn
Mm,
from is already not super high quality. And by the way, I suspect a lot of texts right now are already generated by an LLM or with the help of LLM. So it basically makes the situation worse, right? And so
for sure.
yeah, so that's actually a big problem. How do we teach LLM to learn from the best, and what the best is?
But I think it's not the right approach to think about the LLM on its own when it comes to education, because an LLM has some knowledge, has some memory. He remembers what he was trained on, but there's a limitation when it comes to the data at, until what date the data was provided, the training data was generated, and there will be some uh, cutoff date until which the LLM remembers some facts about a specific subject. So specifically about education, I would not rely on a LLM on its own to be able to understand and establish facts, or through a discussion with a student. I would I would actually make sure that I use a LLM not as a knowledge base, but as a natural language processing layer that would be able to understand where to look for the information instead of thinking about the LLM itself as an information bank. I think it's much more efficient to actually continuously update a typical database of information, a knowledge base, a knowledge database, or a simple database of information that you can easily update on a daily basis, and have the LLM being able to pull that information, process it, and convey an explanation, an answer to a student through a conversation by using that information that is up to date and that has been hand selected by experts.
Oh, I
So
agree.
I would not, I
I
would,
agree.
I would really not rely on the LLM as an information bank. I would rely on the LLM as a way to understand natural language, being able to make a decision on what is the best place to look for the information that is asked by the human question. And uh, it's good at taking some text information, and it's going to improve by being able to utilize additional type of uh, information like visual information to extract that information and process it to provide a concise answer to a potential student. So I think that would be right now the best way to use LLMs as a layer, as a natural language layer to interact with softwares where the right information may be.
For the teacher. Yeah, well, yeah, in general, I agree. Yes, at this moment, right, it is the most sensible way to use it. The question is, of course, can it improve, right, like further, and how much? So
Mm,
the question is, will there be a breakthrough when, at least for certain scenarios, LM can sort of can emulate the human teacher sufficiently well? Uh, Currently, it kind of almost impossible. The teacher may use a model, like you said, right, to sort of come up to improve their materials, or maybe to just kind of get some kind of, uh, like, I don't know, guys, if you remember House MD TV series about Dr. House,
yeah, I
in
guess.
20
Yeah.
years ago, you remember? Yeah, Bhaskar is
Hmm.
too young. So, so, basically, long story short, uh, a genius doctor needed to have five less genius doctors just to talk to them,
Hmm.
right? Not because they would actually give them any good ideas, but just because they would produce some, basically, I don't know, they would just produce, sounds, right? So to speak. They would just talk about it.
Mm,
And somewhere in between, it would cause some kind of association to go off in his head, and he would come up with the right answer, right? But that's actually back to the group learning, right? But he actually needed like five people to talk to on a regular basis to, in the end, ignore them. But whatever they were saying was just useful for your thinking process. So that's basically currently, I think, Damien, you were kind of hinting on the same thing, right? That's basically currently the most maybe efficient way to use LLMs for creative people is not to rely on their output, but sort of to just use them, whatever they're producing, to inspire your own thinking process. Uh,
I'm just saying, no, I'm not exactly saying that. I'm
mhm.
saying that this is a layer between the human and potential software that can
Okay.
contain a lot of useful information. Like if you have a database of textbooks, it's going to be hard for a human to find the right query to get the right information to the question the human may have. And LLM is actually very good at understanding. LLM is very good at taking a human question and translating it into the right query to query the information from a database. And if you actually instruct the LLM to be a Socrates, let's say, teacher, and you augment it by providing it with the right information, it's going to actually being able to distill the right information and provide it little by little to the student in the way that is useful in that Socrates type learning. But you need to augment the LLM, and you need to tell the LLM that the information needs to come from a trusted source instead of ask the LLM to pull its information from its own programming. I think the LLM is good at following some instructions. It's good at translating from human language to maybe some other software language and being able to interact with other softwares. But I would not trust it as an information bank.
Okay, I agree with you. I agree with you there too. Yeah, wholeheartedly. And so, yeah, that's the situation we're in right now.
So let's change a bit of subject.
Yeah.
But Bhaskar, I'm
Yeah,
actually curious. You're teaching on Coursera,
yeah, that's right.
so I thought that only professors could teach on Coursera.
Oh no, it's not like that. So basically, what happened was, I mean, when Coursera launched back in 2012, I was in, still in college, and I took some
Hmm.
time off and started, enrolling in these courses. And over the last, few years, I mean, I have finished more than 200, courses on Coursera with certificates. And
Nice.
I was part of the beta testing group and so on. And then they asked me, will you be willing to or interested to teach at Coursera? So that's how I got to opportunity to teach at Coursera. So back in
Well,
few years back, they launched a project called guided projects. So you
okay,
can teach guided projects, and you can teach regular courses as well. You don't have to be a university professor.
I see. So it's more like a TA.
No, 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 no. You are the person who is teaching, not basically TA. You can
Yeah.
teach the regular courses, and you can teach the guided projects as well, not TA. I mean, you are the only person who is developing the entire course, coming up with questions, using those evaluation metrics that they have internally.
And you do the lectures as well.
Yeah, yeah,
No, that's great. That's great. I may ask you for some advice. I didn't know that regular people, non
you can do.
uh, accredited professors, could actually do it.
No,
Uh,
you can.
that's great. That's great. I used to be addicted to Coursera. You have
Yeah.
200 certificates. I don't have as many, but when I came out of my PhD, I felt I knew nothing else but physics, and I
Hmm.
started to take as many courses as I could on Coursera, and I was addicted to that knowledge that I could not learn, by the typical education. So yeah,
Yeah.
it's a great place to learn. Right?
Right. I mean, me too. I mean, I also addicted to Coursera. Not only Coursera, I like Udacity as well. They have very nice pedagogy to teach about different difficult topics to understand in easy way. And I also like DataCamp, because DataCamp has tried to do something like
Mm.
what Ilya have been trying to do within ITS. So they use some concept called gamified learning. I mean, they will not ask let you go to the next chapter unless you finish the current chapter, the evaluation. So this is something which helps you to bring or to understand the or create the muscle memory that you need to learn
Mm.
programming. So that's data camp for you. They have built in this gamified learning philosophy very nicely in their platform. And I was equally addicted to all these three platforms back in a few years back. Coursera, Udacity, and Data Camp. But now there are so many.
Yeah, yeah, yeah. Well, that's great. That's great. So you're a quant, right?
Yeah.
A quant
Right.
data scientist.
Right.
So tell me more about that. Like, what does that
Yeah.
exactly
Sure.
mean?
Yeah, so I work at BlackRock. BlackRock is the world's largest
Mm-hmm.
asset manager. And again, what will be
Mm-hmm.
speaking is my own personal experience. Not I'm not speaking on my employer's behalf. So all the finance companies traditionally they were always data heavy industry. Right? They always have data, and they always used to build models to create trading signals. But machine learning is very new to this industry. I mean, before
Oh,
machine
really?
learning also, yeah. I mean, there used to be econometricians who are more of statistical modeler. Use statistics, simple linear regression, or GAM models, etc., to create signals in the for to trade in the markets. But machine
So
learning,
sorry.
yeah,
The goal here is to trade stocks What
Yeah.
is it?
Yeah. So it is an
Trade
investment
stocks.
management. Yeah. It is an investment
Mm,
management. So in investment management, we basically manage, clients' money, and clients can be, for example, some, insurance company, some government, so, or, any other, fund, for example, that you are managing, the money for. And, doing data science or doing machine learning is very different in finance compared to other industry, because in finance we're taking very highly risky decision, right? We're managing people's money. If we make a mistake, you're losing money, right? So we are not, when we build models, we're not only focusing on predictions alone. We also try to understand what is the uncertainty associated with the model
yeah,
prediction. Should I trust, or when to trust or when not to trust the model output? And not only that, we also care about interpretability as well, because all these models are being actually used by portfolio managers or the risk managers or the traders. They will, find it difficult to use unless and until they understand how the model is making a decision, right? So, in order to use, machine learning, we do not only care about the prediction, we also care about the other pieces of, modeling aspects as well. And as I said, machine learning to finance is not that mature compared to other industry like retail and e-commerce, etc. As I said, this industry used to be, and most of the modeling used to be, done by econometricians, where they mostly do, statistical modeling to generate trading signals. For example, let's say, or not only trading signals, also for risk management purposes, predicting liquidity
yeah,
risk, or, predicting, default risk, prepayment risk, etc. So, and another aspect, what makes finance different from other industries, we deal with time series data set, and time series data sets are not IID. So you cannot use, some of those traditional techniques as it is. For example, if we talk about cross validation, right, to tune
mm,
hyperparameters, you cannot use
yeah,
the, as it is, or, the way you divide the train test data, you cannot use the, the randoms, division of the, right? So there are so many things in finance which you have to deal in a different way compared to other domains. So this is a very interesting area. I mean, it is not yet matured, and there are so many, areas of improvement is there. For example, we also care about, causal explanation. This is again a very active area of research right now. How do you, find out causality between some events? For example, let's say Silicon Valley Bank collapse, this year in the month of
mm,
March. Can you predict it, a few days in advance? If you can do this, then you can make a lot of money if you already know, what's going to be happen in the next couple of days. And also coming to generative AI, I mean, as Ilya have mentioned already. I mean, generative AI has a lot of use cases, right? I mean, it can be used for, in many, including all the domains. In a specific organization, think about it in HR. Maybe HRs can use when screening, candidates' resumes using generative AI. Maybe your client servicing teams can respond to your client queries in a much faster way. But as a quant data scientist, our objective is to use LLM for creating training signals. So how can you use generative AI? So one of the use cases that many investment managers are trying to find out is, how do you augment your traditional feature space. Just to give you an
mm,
example, it is in public domain as well. So for example, we predict liquidity. What is a liquidity score of a particular security to be traded tomorrow? And generally, I work in fixed income market. If you have some idea about fixed income, is a little bit different from equities market, where equity market is more transparent. They trade it over
mm,
exchanges, but fixed income market, they trade over OTC market, over the counters. So there is a lack of
okay,
transparency. So for example, let's say you are a fixed income trader and you want to buy or you want to sell a particular bond, let's say corporate bond, then you have to go to the market makers or the counterparties or the broker dealers. And here in this case, the market makers or the broker dealers will be investment banks like Goldman or JP Morgan or Citibank, etc. So you would talk to them over the counter, maybe using some Bloomberg terminal or those kind of trading venues, and then you talk to them. Okay, I want to sell this. Can you quote me at what price you want to buy? So there is lack of transparency, and because of lack of transparency, the price that you may get is not a fair price of the bond. So they might charge a very high price. So how do you know that they are not ripping you apart by quoting a very high price? So that's where machine learning comes in. Can you use machine learning to predict the fair price? And the quotes that you're getting from the market makers is very different, then you should not go ahead with the transaction. Or, for example, another model that we have is, predicting liquidity risk. When this global financial crisis happened in, US 2007-8, after that, there has been, rule by the regulator that if you're a mutual fund provider in US, then along with every mutual fund, you need to mention, how much liquid that fund is. Is it highly liquid? Is it highly illiquid? Or is it moderately liquid and so on, based on the regulation?
But how is you said that the LLM helps you build
Yeah,
some features like
right, right,
how does that does that
right. So,
how does
so
that do that?
here, right. So right now, all of these models, predicting fair prices or, predicting liquidity, we don't generally use any text-based features. For
Yeah,
example, just to give you an example, as of now, we don't use any text-based features. But just to give you an example, that those features are also important. For example, back in 2021, there was an event happened. I mean, Cristiano Ronaldo, he was in a press conference, and in that press conference, he actually, removed or switched to Coca-Cola bottles by water bottles,
yeah,
right? And
I
when this
remember.
news actually broke, not exactly on the same day, but after some day, few 2 3 days, after, Coca-Cola actually lost $4 billion in market cap. So this is the
Mm,
impact of news some stocks have, right? Again,
mm,
not all news that has been published for Coca-Cola will be impactful or have, capability of moving the prices, but some have capability of moving the prices. So now, if you know that, Coca, this event has happened, maybe everybody will be trying to sell Coca-Cola bonds, or maybe, in that case, it will increase the demand, and maybe, it will change, it will, have an impact in the price of that bond as well,
yeah.
or it will have impact on liquidity of that bank bond as well. So now, if you want to, find out first, before you want to find out the sentiment, first you need to find out the, those news articles which are relevant, because not all news articles will be relevant to you, right? Some of them can be relevant, some of they can be maybe irrelevant. So think about an era where there is no LLM. Without, the pre-LLM era, if you want to solve this, then you may have to build a model to, find out which one is relevant, which one is not, or maybe to find out sentiment, you again need to build a model, positive sentiment, negative sentiment, so on. But now, you can generate features on the fly. Maybe you come up with some themes, based on these themes, you find out this news is relevant. And if it is relevant, you just, label it as one, if the positive sentiment is positive, or you label it as, negative one if the sentiment is negative. And not only sentiment, also the news story counts. How many news stories have been published by several, media houses. That is also a very good predictor of, liquidity of a particular bond. So now, with the help of generative AI, it has now become very much easier to create, these kind of features at scale, without training any such, model. So that's
Yeah,
what, we have been these are some of the experiments that we are performing, and results seems to be promising as of now.
that makes sense. That makes sense. I had one question because you said that machine learning is new in the
Mhm.
world of finance. Uh, so you what you're doing is portfolio management. Am I correct?
Yeah, right. That's right.
But there's maybe another side of finance, which is high frequency trading, for example, which is,
Yeah.
I think, very different.
Yes.
I would assume that machine learning has been very useful for a long time there.
Yeah, I mean, I don't see, much, research there in high frequency trading. Maybe, they have been doing machine learning, but when I see, some papers, especially in finance, I don't see, much of the research that has happened. For example, I think people have been trying to do reinforcement learning. I see a lot of, reinforcement learning papers as well, in high
Mhm.
frequency trading, or, to, build smart order router, which way to direct your orders to. But again, I see only those, in papers. In implementation, very few companies have been able to do real implementation, I guess. Again, I'm not, sure, but I don't see, real world implementation of those, algorithms in finance. Because as
I'm
I said, I
surprised
mean,
about it.
in finance, as I said, right? I mean, we not only care about, the model output, we also care about a lot of things like, interpretability, uncertainty, And also the quality of the data is also very important. And because in finance, the noise to signal ratio is very high. The data sets are not that, of high quality. So another aspect is the data sets are also very sparse. For example, fixed income, they don't trade very often like equity. I mean, if you have a bond,
Mm,
then maybe that bond, maybe trading every 1 month or every 2 months.
mm.
So that brings up a lot of other challenges as well. That how do you handle the
Yeah,
spark, the quality, etc.
yeah, yeah. Well, to come back to high frequency, which
Hmm.
can trade multiple times per second,
Hmm.
you cannot have a human taking the
Yeah,
time to
yeah,
assess the risk
yeah.
visually, with some numbers, and to try to understand the interpretability of
Mm,
what a model would come up with, right? It
right.
has to be done in an algorithmic fashion,
Mm,
and there being a lot of strategies like algorithmic strategies
yeah,
to do some high frequency trading.
right.
I would assume that a machine learning algorithm would have its place when it comes to making decisions
I
about a
think
trade.
you're right. I mean, in high frequency trading, you're right that we do algorithmic trading, but I think it's not that machine learning algorithm. It's maybe, simple rule based, algorithm.
Oh
Let's
yeah.
say the bid ask spread between, the prices. If it is, certain basis point, then you do buy or then you do sell. Yeah, maybe those kind of, simple heuristics or rule based algorithms they have under the hood. But I don't think machine learning, they use machine learning there as of now. I don't think so.
Okay. Well, you I remain suspicious a bit about that statement. So I will look
Yeah.
a bit at if some other people say the same thing. So
Yeah.
to come back to portfolio management, which is what you do, right?
Hmm.
What type beside LLMs, what type of machine learning models, algorithms are you using?
Yeah. Yeah, so mostly I mean, at the time of experimentation, we experiments all the available methodologies that we can try just to see how much additional benefit we can use, we can get by using neural networks, for example, right?
Mm-hmm.
But again, neural networks we don't deploy in production, although we do some experimentation because of the same reason of interpret uncertainty, etc. But generally, we use tree-based models. Mostly tree-based models are
Okay.
in production. But if you talk about the econometricians, they will always use statistical models like simple linear regression or you know
Mm.
um, the GAN models because their mindset is very different. They come from a different school of thought, and the machine learning professionals their mindset is different. And although random forest is also not a very interpretable by design, but you can certainly use post hoc explanation tools like SHAP, which is the state of the art right now, to explain at an individual level prediction. But again, there are few more other techniques available, and there are different definitions of interpretability as well, right? Like causal interpretation, which SHAP cannot give
Mm.
you right now. But these are
Yeah.
some active areas of research which we're trying to solve and trying to implement in real world applications. But yeah, it is mostly tree based models that goes to
So
production.
tree-based models, that means that it's a supervised learning algorithm.
Yeah, right.
And what are you trying to predict when you try to optimize portfolio?
Yeah, so portfolio optimization directly does not use this machine learning, but machine learning is a subset of portfolio optimization. For example, in portfolio optimization, you want to maximize returns while minimizing risk, subject to some constraints. And those constraints may be, for example, liquidity risk is one such constraint that you don't want risk to be higher than certain points, for example. Now, how do you predict liquidity? That's a very difficult problem to solve because liquidity have so many dimensions. There is no one single definition of liquidity, and that's where
Mm-hmm.
we do data driven approaches to predict liquidity. Now we have one model to predict liquidity of a bond. We have one model to predict transaction cost, for example. So transaction cost is another important criteria while you build your portfolios. For example, you don't want to have your very high transaction cost. All right. So those are individual models, and those models helps you to predict liquidity. Those models helps you to predict transaction cost. And once a model predicts these numbers, those numbers are being used by portfolio managers while creating their portfolio, while optimizing their portfolios.
I see. So those are pure insights for
Yeah,
for human to make a decision.
right. And this liquidity model, as I mentioned, this is not the only use case where the portfolio managers use to optimize their portfolio, but there are several other use cases as well. For example, let's imagine yourself as a portfolio manager, and I am
Hmm.
one of the investors. Let's say I have invested some money in your fund, and now I see the market is doing very bad, like the COVID situation or the Russian invasion of Ukraine, and I got panic. I think that my assets will go down. Then I'll come to you and I say, okay, I no longer want to get invested. I want my money back. So this is known as
Hmm.
redemption. We call it as redemption risk. So managers also need to find out, what is the redemption risk they might, have in next, 7 days or next, 1 month, for example. So that also, one of the use case of liquidity, because if we know the liquidity score of a particular bond, then we can find out, how many days it will take to liquidate a particular asset in a bond. Because if the markets are very bad, then everybody tries to sell, but nobody tries to buy, right? So it will go, very illiquid. So if it goes very illiquid, then how many days it will take to, liquidate particular, asset in a particular portfolio. So, and again, another use case is regulatory requirement, as I mentioned already. Nowadays, regulators are, very watchful about these funds because they don't, want that kind of, financial crisis kind of a situation that happened in 7, 8. They want every fund manager to mention, how much liquidity this particular fund has. Is it highly liquid, less liquid? So those classification we also do. I mean, one of the use. So I mean, in one model, multiple use cases.
Um, so my question is this: when you use supervised learning algorithms, you need to input some features, and in the
Mhm.
context
Yeah,
of portfolio management, what I'm guessing is that you have some time series
right.
of assets or stocks. And my question is, so when you use interpretability techniques, what you get is that you get that a specific feature
Mm,
has more impact into
right,
predicting a specific outcome.
right,
So how is that useful for a portfolio manager?
right. Yeah. So basically, first of all, it brings trust to the portfolio manager. And for example, let's imagine, we have a model to predict ADV of a corporate bond. ADV stands for average daily volume to be traded tomorrow. So let's imagine you are the portfolio manager, and our model, predicts, let's say tomorrow, the ADV for Tesla corporate bond is 5 million USD.
Hmm.
But the portfolio manager, because they have been in the market for so many years, based on their understanding of the market, they feel that it should not be 5 million, it should be 10 million, or let's say it should be
Hmm.
1 million, for example. Then they will come back to you and ask this question, okay, based on my understanding, it should be 1 million or 10 million, but why your model is predicting as 5 million? Can you tell me why? So there we
Hmm.
use this explanation framework. And not only this, I mean, we also ship these models to our clients. We have, more than 100 plus, clients who also consume our model output. They also keep asking this kind of, questions like,
But
why?
I understand the reason for wanting to have an explanation of why we get this kind of prediction, but the model is going to tell you this bond has the most impact to the prediction. How is that useful to explain to the portfolio manager?
Oh yeah. So before we build any kind of model, I mean, yeah, that's a very good question because in machine learning models we generally capture correlation, not the causation, right? So this piece is done even before we start building the model. In the brainstorming phase itself, we talk to the portfolio managers, we talk to traders, we talk to risk managers, and we brainstorm with them. What features you want us to include in the model, because it should be, not only be predictive of the target variable that we're predicting, but also it helps us to explain the model output. So we involve, the human in the loop while selecting the features, and based on their understanding, we use those features, we experiment with them, and whatever are the best features, we keep them. And those features are coming from the end users who is going to use those models.
So I'm guessing that you will have two different sets of features. You would have
Mhm.
features that are useful to actually good to get good
Yeah.
predictions, and
Yes.
you have features that are useful to get good interpretability.
Right.
But those two sets of features could
Right.
interact in a negative way to provide good interpretability uh, for the prediction, right?
Yeah, I mean, right. I mean, but as of now, mainly, whatever processes we follow is we always, talk to our stakeholders first. What is their, understanding of the problem statement? I mean, they come up with the business problem, then we convert that problem into a data problem or into a ML problem. And based on that, we brainstorm the features with them. I mean, yeah, of course, there can be some other features, which might have very good predictive power, but that predictive power may be because of some lurking variable or confounding variable under the hood, but they don't have that intuition. If they don't have that intuition, let's say there is a variable XYZ, and we found as a data scientist that XYZ variable or feature has very good predictive power, helping us to predict, but they don't understand, they don't relate to XYZ, then most likely will not use that feature because we know we want their intuition as well, our end users' intuition as well, while they consume our model output. Because as I said,
Hmm.
in our world, model output or the accuracy is of course important, but along with accuracy, the interpretability is also very important, or the uncertainty is also very important. So this is the process that we generally follow, which is kind of different from other industries.
So, if a portfolio manager makes a decision based on some insights coming out of a machine learning model, whatever
Mhm.
that insight may be,
Yeah.
interpretability or some predicted outcome, uh, is there a world where we can remove completely the human portfolio manager and have a
Yeah.
model that utilize those insights to make a decision?
No, not as of now. Not as of now. Yeah. So, yeah, when I mean, there are some ideas coming up. I mean, this idea is not new idea, but it has been there in for so many years called robo advisors. That you have a robot advising you where to invest, where not to invest. But you don't see companies like big companies like BlackRock or even JP Morgan. They have used in production. So these ideas are still there in research, but I hardly believe that they have been using in production. And why? Because we are taking very highly risky decision. Even one mistake you make, you lose, millions of dollars. And the cost is very high. I mean, the cost of error is very high in financial applications. In those applications where cost is not very high, maybe you can completely, remove that particular human element. But in a portfolio optimization, case, I don't think, we are there yet to replace the portfolio managers completely as of now.
But I understand that the risk is very high. But if we actually provide to a model all the information that a portfolio manager has to make a decision,
Mhm.
uh, we could encode the concept of risk in an algorithmic fashion. So that's not
Yeah.
something that is too hard to do. Um
Yeah, but there is
why?
no, but yeah, I mean, there is no proper definition of risk, right? For
Okay.
example, as I said, that our models, we have not used, those NLP based features like the incident that I mentioned to you, what happened with
Mm-hmm.
Cristiano Ronaldo, right? So now, how do you make sure that you have all of those signals that might impact financial markets, right? And financial markets are very dynamic. For example, one, alpha that you generate, maybe, next month or next week, the same alpha might not be making you money, for example, right? So the definition of risk, the definition of rewards or returns keeps on changing in financial markets because of its dynamic nature. So that's why it's very difficult to define the risk, where which will be an universal definition. There is no such universal definition. That's why it becomes difficult to completely eliminate human element from these models.
So I think that makes sense that we don't know how to well define risk. But I think what you're saying implicitly is that the portfolio manager makes decisions
Yeah,
based on some data
right.
that is not coming out of a machine learning model or that is not directly inputted into a machine learning model. right?
Yeah, right. So not only, yeah, that's right. So portfolio manager is not only, consuming machine learning model. Machine learning model is just one tool in the portfolio manager's toolset. For example, we
Okay.
predict, transaction cost. We predict, ADV. Now it is up to the portfolio manager whether he wants to use it or not. So it is just they use it as a tool in their toolbox along with, several other things.
But what other things the portfolio manager is using to make decisions beyond the insight coming out of a machine learning model?
Yeah, I mean, so basically, portfolio managers also get, directions, from, clients. For example, let's say you are a,
Okay.
you're an insurance institute and you have, directed, you have given a mandate to a portfolio manager that, you invest this much amount in this particular thing, you invest that much amount in this particular asset. So apart from the machine learning models, or apart from the signals that we generate for them, they also get mandates from their clients and they use those
Okay.
mandates as well while designing their portfolios.
So thank you guys for joining this podcast today. That was a great learning experience for everybody, I think. And I'm looking forward potentially to see you soon again here. So thank you guys.
Thank you so
Yeah,
much.
thanks, Damon. Thanks for having us. Yes. Bye bye.